Welcome to Cognition Chunks. This information is for entertainment only. I am not trained in physics. Is this useful? Is this nonsense? Join me as I attempt to learn from GPT. Here is Timeless Physics by GPT. Episode 8. Time-Independent Schrödinger Equation. Hey everybody! Welcome back to our channel where we dive deep into the fascinating world of physics and unlock the secrets of the universe together. Today we're tackling a heavyweight champion in the world of quantum mechanics, the time-independent Schrödinger equation. This isn't just any physics concept, it's the key to understanding how particles behave in a completely timeless setting. Get ready, because this is going to blow your mind. What is the time-independent Schrödinger equation? Let's start with the basics. The Schrödinger equation is a fundamental formula in quantum mechanics that describes how the quantum state of a physical system changes over time. However, when we talk about the time-independent version, we're focusing on a specific snapshot where time doesn't play a role. This equation looks at systems that are steady and unchanging, like an electron in an atom that's not excited by external energy. Why go timeless? You might be wondering, why do we even need a time-independent equation? Great question. In quantum mechanics, simplifying equations by removing the time component helps us solve some incredibly complex problems. It allows physicists to find out what's called the stationary states of a system. These states are crucial because they describe systems that are stable over time, like atoms in their lowest energy levels or ground states. The time-independent Schrödinger equation is, well, like the powerhouse of quantum mechanics. It gives us the energy levels for electrons within atoms and tells us about the structure of molecules. It's fundamental to understanding everything from how your microwave heats up food to why the sun shines. This equation doesn't just predict behavior, it explains the very nature of matter at the smallest scales. Imagine if we could see quantum particles as waves, vibrating at different frequencies depending on their energy. The time-independent Schrödinger equation helps us visualize these invisible waves. It tells us where a particle like an electron is likely to be found around a nucleus and describes its behavior as a standing wave, kind of like the consistent vibrating patterns you see on a plucked guitar string. Now, you might be thinking that's cool and all, but how does this affect me? Well, the technologies that power and innovate our world, from lasers and semiconductors to MRI machines in hospitals, are all based on principles predicted by quantum mechanics and the Schrödinger equation. Understanding these principles is key to advancing technology and science in ways that improve everyday life. So there you have it. The time-independent Schrödinger equation isn't just a set of symbols on a piece of paper, it's a fundamental descriptor of the quantum world that impacts both the universe's grandest and tiniest scales. It shows us that sometimes to really understand complex systems, we need to take a moment, pause time, and dive into the timeless. If you found this dive into quantum mechanics fascinating, don't forget to hit that like button, subscribe, and ring the bell for more awesome content. Got questions or ideas for what we should cover next? Drop a comment below, we love hearing from you. Thanks for watching, and remember, stay curious, keep exploring, and as always, keep asking why. See you in the next video. Thank you for joining us for another Cognition Chunks.